Quiz 7, key. So the first step in quiz 7, you'd recognize, hopefully, that there's a halogenation. So you see the Br2, but you also see a polar protic solvent. So if you see a polar protic solvent, SHs, OHs, NHs, and PHs, you recognize that they're part of the mechanism probably. First step in halogenation, 3 arrows. Pi bond reacts, bromine-bromine bond breaks. The bromine that initially got reacted with, lone pair comes back. You form a bromonium ion, 3-membered ring. It comes from the top. This point, Br minus or the solvent react. If you have a polar protic solvent, that'll react. It'll react on the more substituted carbon. All right, so it's going to react on the SN2-like on the more substituted carbon. There, break that bond. You notice that these two things, the bromine and the solvent that adds, are anti. Make sure we balance our charges. There should be a plus charge there. We're going to need a deprotonation. That's going to make HBr, and that's going to create our final molecule. Now, at the end, we ask ourselves, did we make an asymmetric center? Do we have something that's sp3 hybridized that's bonded to 4 different things? So here we have two H's, so that's not it. At this carbon, we have an H, a tert-butyl, a phosphine, and then this piece. So this is an asymmetric center, so we had to put plus an enantiomer here as well. All right, problem number 2. Give the mechanisms and products for the reaction sequence below. You have an alkyne and HBr, one equivalent, so you got to check the equivalences. That's one thing to look for. Pi bond reacts, you break the HBr bond. You make a carbocation on the more substituted carbon. This is a terminal alkyne, more substituted carbon. Make sure you balance your charges. There's no polar protic solvent. So all it is going to be the Br minus lone pair. It's going to react there. And you're going to get this alkene. From this alkene, yes, it doesn't matter if the carbocation's here or here. It doesn't matter at this point. Nope, doesn't matter. Alkene reacts with mercury and water and sodium borohydride. This is a way to add OH and H in an anti-fashion. We should recognize that. Need at least 2 arrows. Adds there. Again, polar protic solvents involved. It's going to go to the more substituted carbon, that Markovnikov, in an SN2-like reaction. We're going to need a deprotonation, the last step here. So deprotonate. So now we have the OH and the mercury on there. And the last step, the NaBH4, what that does is replace the mercury with a hydrogen. NaBH4 just replaces the mercury with hydrogen. Don't need to know the mechanism there. Again, at the end, we ask ourselves, did we make an asymmetric center? If we did, we would have an sp3 hybridized carbon bond to 4 different things. Here we have 3 H's. That doesn't work. Methyl, bromine, OH, and a methyl. Actually, whoops. This is not an enantiomer. I take that back. Right? This is not an enantiomer because methyl and methyl. So it's not 4 different things. All right, it has to be 4 different things. That's a methyl, CH3, that's a CH3. So it's the same thing. 2 of the same things, so it's not an enantiomer.